All right, so section 4 is all about parametric equations. You've never heard of them, but we're not going to do much more than just this one section. You will not see this pretty much the rest of the year. But it is something I think is important to at least give you an introduction to, so if you see it in college that you're more comfortable with it. Okay, so typically we usually use y as a function of x and only use x and y as our variables. So first of all, it starts out saying a relation is just any set of ordered pairs. The graph is just the set of points that correspond to the ordered pairs. All right, so notice in this first example, not only do we use x and y, we also use the variable t. So we have x, x as a function of t, and we have y as a function of t. And think of what does t normally stand for? Time. So we use this in a lot of different situations, but the good news is I just want to introduce it to you in this section. Okay, so they give us two equations, and they give us the domain of t. All right, t has to be greater than or equal to 0. So first we're going to graph it. So we're going to create a table where we're going to have three variables, t, x, and y. This tells us where we're going to start. 0. Now, notice what we're going to do with the t values, take the square root. So I'm going to choose my t carefully. 0, 1, and 4, because that'll allow me to have nice, easy numbers. I'm then going to plug all of my t values in for t here to calculate what the x is. So if I plug 0 in, the square root of 0 is 0. Plug 1 in, x equals 1. Plug 4 in, square root of 4 is 2. Then we're going to calculate the y values. So I plug each of my t values in for y and for t to calculate y. And since they're the same, all of my y values equal my t values, so there we go. Next, we're going to graph. Now, when we graph, I'm going to graph on a Cartesian plane, which is just x and y. So we have 0, 0, 1, 1, and 2, 4. So notice, now, this is the very first point. We call this the initial point. And it says, indicate the direction in which the curve is traced. So as t gets greater than 0, that means I'm tracing it this way. So I start it at 0, 0, and I'm going to put little arrows along the way that I'm moving in this direction. Okay, so you can see this ends up being half of a parabola. Our goal is to substitute back and forth here so that I only have x and y. Now notice since y equals t, I can just replace t with y over here. So that is one option. We can use x equals the square root of y. Now think about if I'd square both sides, you'd get x squared equals y. This, though, would be the whole parabola. We're starting where x is greater than 0. So you can either use this and stop here. You can also use this one. It doesn't matter. But if you use the full equation of x squared, you have to qualify it with x is greater than or equal to 0. All right, so here's just some definitions. So first of all, we have x being a function of t, y being a function of g. If you want to copy that whole thing down, that's fine. That's your big definition. If you need to pause, if you want to write it down, fine. You don't have to, if you like having it though. This is where it's really important. The variable t is the parameter. Everything's in terms of t, so we call it the parameter. So I'm going to point this out. the initial point. So if we're given a domain, a closed interval, A to B, this is the first point I'm going to plug in. I'm going to plug A into F. So we say F of A is our X value, because look up here, F tells us the X, G tells us the Y. So our initial point, I'm just going to call it IP for initial point. And G of A is my Y value. Then I'm going to say TP for the terminal point, where it ends, terminal. That's going to stop at B. So my terminal point, F of B, gives me my X coordinate, and G of B gives me my Y coordinate. So those are the main things you want to notate in your notes. Okay. So we're not going to do the activity, but this is going to show us circles, what circles look like with parameters. All right. The most important thing to always start with is the interval that you're given. Always circle it, write it down, pay attention, because if you do anything that's outside of that, you're going to miss points. So be very careful. The second thing I want you to notice, these are all in terms of sine and cosine. So we haven't reviewed that. That's going to be section 6. So we're going to get a little crash course on remembering the sine and cosine curves. So when drawing the sine and cosine curves, we talk about pi. Don't freak out if you don't remember, that's okay. This is how we always start with sine and cosine. So sine starts at 0, goes up to 1, back to 0, down to -1, back to 0. Remember that curve? That's sine. We're going to do the same thing with cosine. Notice my interval marks are the same. We always go up by pi over 2. We'll talk a little bit more about that when we get to section 6. But the cosine curve starts at 1, then goes to 0, -1, 0, 1. So that's my cosine curve. So we're going to use that just as a reference in just a minute. So remember I said I want us to start with a table, and we're going to plug in all of these points over here, because we start at 0, and I got to go all the way up to 2 pi. So we're going to use pi over 2, pi, 3 pi over 2, and 2 pi. These are my t values. I'm going to now plug each of these in for x. So right here. So if I plug 0 in here, I get 2 times cosine of 0. Cosine of 0 is 1. Times 2 is 2. Cosine of pi over 2 is 0. Times 2 is still 0. Cosine of pi is -1. Times 2, -2. Cosine of 3 pi over 2 is 0. And 2 pi is 1. So notice when we plug these values in, these are along the x-axis, and cosine of that value is the answers along the y. Okay? Now I'm going to do the same thing to find my y values. Now I'm going to use the sine curve. So plug 0 in for sine. That's right here, 0, 0. So my y value is 0. Plug pi over 2. That's 1 times 2. Plug in pi. That's 0. Plug in 3 pi over 2. That's -1 times 2. And plug in 2 pi. That's 0. Okay, now we're going to graph this. So we're going to use our x and y coordinates. So 2, 0. This is my initial point. See how it says find the initial and terminal points? You can either mark that in your table or you can even mark it on your graph. So we begin at 2, 0, then we're going to go to 0, 2, then we go to negative 2, 0, 2, 0, and back to 2, 0. Okay. So I'm going to go in this direction. When it's the whole circle, please make sure you're indicating the direction you are traveling. Okay. Notice the initial point and the terminal point are the same. The hardest part for everybody tends to be finding the Cartesian equation. So one of the most common trig identities that you guys should have learned last year is sine squared plus cosine squared equals 1. If you have your textbook, if you open up the inside cover, you may see this equation. This is one of the most important equations for your identities. And you'll remember it if you didn't remember it right now. That's okay. So our goal is, how do we find sine squared out of this equation up here? So if I start with, let me just write up here, y equals 2 sine t, I'm going to get sine by itself. So divide by 2. And then what do I do to get sine squared? I'm going to square both sides. And remember, when you square sine t quantity squared, that's the same thing as sine squared t. That means the same thing. So I can replace sine squared t with what it equals. And I'm going to go ahead and just make that y squared over 4. Plus, now I'm going to do the same thing to get cosine squared. I'm going to make some room. So I'm going to do the same thing with the x. So if x equals 2 cosine t, I'm going to divide by 2. Then I'm going to square both sides to get cosine squared. Then I can substitute x squared over 2 in place of cosine squared. I'm going to go ahead and just square each one. Okay. Now, you can leave it like this, but I want to show you something. If we multiply everything by 4, we get y squared plus x squared equals 4. I'm hoping that you kind of remember, if you have x squared and y squared equaling a number, it's a circle. All circles have the equation x squared plus y squared equals r squared. Notice the radius is 2, so the radius squared is 4. All right? That's the area, or the graphing a circle. Now let's look at the ellipse. So they kind of cheat a little and show you the general equation of an ellipse. And we'll use that in just, I'll show you how that works in just a little bit. I want to actually get a little more room. We're going to do the same thing though. So always start by looking at your interval for t, because we're still dealing with sine and cosine. For t, I need 0, pi over 2, pi, 3 pi over 2, and 2 pi. And I need to calculate my x and y values for each of these t values. So to find my x values, I'm going to plug each of my t values in for t. So if you didn't graph the sine and cosine from before, you might want to move the video back and write those at the top of your notes somewhere. You're going to need that. You need to be able to just know that, but I don't expect it right now. So if we plug 0 in for t, cosine of 0 is 1, times 3 is 3. Cosine of pi over 2 is 0, times 3 is 0. Cosine of pi is negative 1, times 3 is negative 3. Cosine of 3 pi over 2 is 0. And we're back to 1 times 3 is 3. Do the same thing now to find our y using 4 sine t. So sine of 0 is 0 times 4 is still 0. Sine of pi over 2 is 1 times 4 is 4. Sine of pi is 0. Sine of 3 pi over 2 is negative 1 times 4 is negative 4. Sine of 2 pi is 0. All right, let's go ahead and graph. So this is my initial point because this is my beginning of my interval. This is my terminal point because that's the end of it. I can indicate that either on the table or on my graph. 0, 4 is my next point. Negative 3, 0, 0, negative 4. I'm starting here. Oh, that's bad. I'm starting here, going all the way around, moving in this direction. And I end, my terminal point ends at the same spot as my initial point. All right, so finding our Cartesian equation, we do exactly the same thing. We're dealing with sine and cosine, so I'm using my sine squared plus cosine squared equals 1 as my basic identity. I have to get sine squared out of this. So if we start with y equals 4 sine t, divide by 4, square both sides. So sine squared is y squared over 16 plus, now I need to get cosine squared. So I'm going to use my, I'll just write that under here. X equals 3 cosine t. Get cosine by itself, divide by 3, square both sides. So I have x squared over 9 equals 1. So when we look back at the equation of an ellipse, x squared over 9 is x squared over a squared. What that means is the x direction, I go 3 each direction when this is 9. Y squared over 16, y squared over b squared. That means the y, I go up 4 and down 4. So that matches that. Okay, that's an ellipse. Now I've got 2 examples of lines, and we're not going to do that. All right, so lines, graphing the line segment, I think is pretty straightforward. We start here, we end here. How many points do we need for a line? 2, so we don't even have to give extra stuff. We still have t, x, and y. Always start with the table. Initial point, terminal point. So we're going to start with 0 and just do 1. So I'm going to plug 0 in for my t. So 3 times 0 is 0. Plug 1 in for t. 3 times 1 is 3. Those are my 2 x coordinates. Then I'm going to plug 0 in for this t. 2 minus 0 is 2. Plug 1 in. So 2 minus 2 ends up giving us 0. So we have 2 coordinate points here. And this is telling us it's a line segment. So I graph 0, 2, 3, 0. This is my initial point. This is my ending point, terminal point. I'm going in that direction. All right. Now it says identify the graph or the equation is what it's talking about. We already drew the graph. So notice that this equation, we've got 2 points that intersect the y at 2. So if we think of our y equals mx plus b, I can just write the equation of this line because my slope is down 2 over 3, negative 2 over 3x plus 2 because my y-intercept is 2. But I'm going to show you something else that ends up being kind of easy. we could just substitute using these two equations. I'm going to solve for t here. If x divided by 3 equals t, look at the y equation. Y equals 2 minus 2t. Well, if t equals x over 3, I can just substitute x over 3 in place of t. And if I simplify that, negative 2 times x over 3 is just negative 2/3 x plus 2. If I write that in the same order, same exact equation. All right, so to me, this part isn't too terrible. But I want you to pay attention because we're going to use this kind of information to do the last example. Because at the last example, they want us to come up with what x equals, what y equals, and our interval for t, if it's a line segment. I'm going to tell you right now, every single time you do a line segment, you will choose this interval for t every single time. Now notice the format. X equals 3t, y equals 2 minus 2t. I'm going to tell you some general. You're going to have an x value plus at. You're going to have y equals a y value plus bt. And always use this interval. You might want to write that down as we turn the page for parameterizing a line segment. So we're given 2 points. I'm going to choose t to be 0 and this to be my initial point. I'm going to choose t to be 1 and this to be my terminal point. So first I'm just going to write down my t interval. Now let's think about x equals x1 plus at. So when t is 0, x is negative 2. X equals my x coordinate plus, if t is 0, I get x equals negative 2, right? So what I'm going to do, let's move forward. We need to figure out what is a, so then I'm going to plug in when t is 1. Okay, let me do this because you might be confused. This is when t equals 0, x equals negative 2. Now let's write an equation for t equals 1. We keep this general point from 0, and then we're going to use this point, this x and t is 1. So when x is 3 and t is 1, I get 3 equals negative 2 plus a, add 2. So it allows me to solve for a. Now let's use the y equals y1 plus bt to find our second equation. Oh, I'm going to go ahead and write my final. X equals negative 2 plus 5t. So if you compare that back here, that's like this equation here. This one just started with 0 though. All right. Now, when t is 0, y is 1. So this is when t is 0, just like up here, when x was 0, or t was 0 for x. Now I'm going to use this and create for when t is 1. So I'm going to use my y value, and t is 1, so 1 times b is just b. That allows me to solve for b. So then y equals 1 plus 4b. So think of this y1 and x1 to correspond to when t is 0. Then we choose this point when t is 1 to find our b value. Oh, shoot. That's t, right? This is the b value. I need to keep my t. So this is our parameter for this interval. All right, so a little confusing. Don't stress too much. Just try and work your way through it. And we'll talk more tomorrow.